Hello, fifth graders. Mr. Godnick here. I'm going to do lesson 17.8 with you today, which is all about understanding division of fractions. Now we're going to do it a little differently today. When you get a look at the poster behind me, you'll see, yes, we're going to go over the guided practice problems on page 915. But we're also going to come up with a new strategy for solving some of these problems more efficiently. Because even though this lesson is about understanding division of fractions, and we certainly want to understand and be able to reason through it a little bit, we're also going to be dividing fractions a lot as we go forward, as you go forward into sixth grade and middle school. And I want to make sure that I leave you today with an efficient strategy, so that as you get to more complicated problems, you know that you have a way to solve it quickly and easily and make sure that your answer is accurate. So some of my class, you know this already, it'll be a nice refresher for you, and everybody who hasn't heard it yet, this will be a new strategy for you to practice as you go through the rest of the page and see if it helps you get through the answers to something that can be difficult for people a little more easily. So first, let's go over some of the reasoning and make sure we do understand it with the guided practice, and then we'll talk about our new strategy for solving them. So on the guided practice on page 915, okay, number 1 asks you to do some reasoning about whether your answer, the quotient, when you divide, is going to be greater than or less than the numbers that you're working with. So the question specifically in number 1 asks you about this type of problem, a fraction as the dividend divided by a whole number as the divisor. You can see I've already written the answers up for you to check. Your answer in this case is going to be less than. If I am starting with a fraction, and when we say fraction in this lesson, we mean not the improper ones that are really just mixed numbers in disguise. We mean the fraction that is less than 1, like 2/3 or 3/4 or 1/2. I'm starting with something less than 1, a little fraction, and I'm cutting it up even more. So as I cut it up into more pieces, then certainly my answer, my little pieces, are going to be smaller than what I started with. So that one I think is the easiest one for us to kind of think about. The other ones get a little trickier thinking about, so what I want you to remember is the generalization for the next two. If my fraction, again, less than 1, if I have something less than 1 as my divisor, my answer is going to be bigger. So if I start with a whole number, like 3 apples, pizzas, whatever, and I'm dividing it by a fraction, that means I'm trying to figure out how much of that little bitty fraction is going to fit into what I started with. How many pieces can I make? And if I'm talking about a small little fraction, I can make a lot of pieces. So my answer is going to end up bigger than what I started with. Okay, same thing if I'm doing fraction divided by fraction. Because my divisor is something that is less than 1, my quotient, my answer is going to be bigger. So that's just a generalization for you to remember. And it's a way to check and see if you've done the answers correctly, if they're reasonable, or maybe you need to go back and check again. Number 2 asks you for how many 2/3 foot pieces can you cut from a 10-foot long board? They want the division sentence that goes with that. So here we go. I'm starting with the 10 and dividing by 2/3. So it's this type of problem right here, a whole number divided up into fractional pieces. Okay, I'm not going to go through how to get the answer yet because we're going to use our new strategy to work with that, but the answer is 15. So if you already tried it on your own, okay, or you could draw it a number line like we saw in the solve-in chair a couple pages ago, and you could cut it up into 2/3 pieces, and you come out evenly with 15 of them. So it does fit our generalization. I'm dividing by a fraction less than 1. I got a bigger answer than what I started with. Okay, here we go, number 3 and number 4. They drew pictures for you, models. You just have to figure out what the models are showing you. So in number 3, I'm clearly starting with 2 wholes. The number line goes from 0 to 2. Even though I didn't cut it very well, if you look in your book, you'll see the more even pieces, and you can tell that each whole number is cut into 3 pieces. So I know it's divided into thirds. And they have circled 2 pieces at a time. So I'm dividing into groups of 2/3. 2 wholes divided into groups of 2/3. How many groups can I make? 3. Okay, and then number 4 has a picture where I can see there are 6/8 shaded. So for your dividend, you can either have 6/8, or if you wanted to put it in simplest form, that would be 3/4. I'm dividing it into two parts because I can see this top part is not circled, but the bottom part is, and they're equal. So I've taken my 6/8 or 3/4 and divided by 2 into two groups. Each group has 3/8 in it. So again, that matches our generalization because I have a fraction. I'm dividing it into a whole number, so my answer should be less than, and it is. 3/8 is obviously less than 6/8. Okay. Now is the moment you've all been waiting for. It's time for our strategy to get this done quickly and easily. No more thinking or reasoning, just get the answers correct. Boom, boom, boom. Okay. I like to call it KFM. Do not get it mixed up with KFC. KFC is fantastic fried chicken. KFM is a fantastic strategy for dividing fractions, which most people don't like to do. It stands for keep, flip, multiply. Meaning, whatever the first number in your equation is, keep it. Leave it alone. Okay? If it's 2, it's 2. If it's 10, it's 10. If it's 6/8, it's 6/8. We're not touching the first number. It stays exactly the way it is. But the second number is getting flipped upside down. That's what flip means. If I have a fraction, I can flip it upside down. So the numerator is now the denominator, and the denominator is now the numerator. If I have a whole number, now is the time to remember that I can turn any whole number into a fraction just by putting a denominator of 1. So for example, if I have something like 3, I'm not changing it to make it 3/1. That doesn't change anything because remember, the denominator of a fraction means how many pieces are in each whole. So if I have a whole number, it hasn't been cut up at all. That means everything is still in one whole piece. So a denominator of 1 is just a different way to show the same thing. Let's say this is 3 apples. Well, I have 3 apples, and each one is one whole apple. I haven't cut them up into halves or thirds or anything. So I can make it look like a fraction by putting a denominator of 1 without changing its value. And that way it's easier to flip it. Okay. And then the M stands for multiply. Instead of dividing, we're going to multiply. And most people find that much easier than dividing. We know the strategy for multiplying fractions. Multiply the top, multiply the bottom, and we can use that to divide. Okay, so let's see how this works. First, we're going to go back to a couple of the problems we've already done so I can prove to you that this will get you the right answers without using a model or a number line or any of those other strategies that might be a little more time consuming. Okay, so if I go back to page 913, here's our solve and share. We did 10 divided by 1/2. If you look back at the previous slide, you'll see I drew a number line. I cut it up, I circled all those pieces, I counted them up, I finally came up with the answer of 20. Watch how quickly I can do it with this strategy. Keep. The 10 stays the same. Flip. Whoop, upside down. The 1/2 becomes 2/1. And then, instead of dividing, multiply. So instead of doing 10 divided by 1/2, I can do 10 times 2/1. And as we just talked about, if the denominator is 1, that means it's a whole number. So really, this is 10 times 2. Yep, there's my answer, 20. Check. Okay, same thing with the convince me problem. Again, look back at the other side of this slide. The convince me problem on page 914 asked you to do 5 divided by 3/4. Let's see if I can get the same answer. Remember, our answer was 6. We could make 6 pieces and there's some leftovers. Let's see if it comes out the same way. Keep the 5. Flip the 3/4, so now it's 4/3, and instead of dividing, multiply. 5 times 4/3. So I know this is a whole number, so I can just multiply the top. 5 times 4 is 20, and then thirds on the bottom, 20 thirds. Now I have to do my division. 3 goes into 26 times, and yes, there's a remainder, but that doesn't matter because I wanted to know how many pieces, which is 6, and I'm done. So far, so good. Okay, let's go back to the top of this page. I know I haven't looked at it in the slides or anything yet, but if you look at the top of page 915, it gives you another example. And I want to make sure I get a fraction divided by a fraction in here because that's a problem we haven't talked about too much this year, but you're going to see a lot of them in the future, and this is supposed to be getting you ready for that. So the top of this page where it says another example asks you to look at 3/4 divided by 1/4. And they tell you in this little number line display they did that the answer is 3. Let's see if we can get the same answer with KFM. 3/4, keep it. Still 3/4. 1/4, flip it. Now it's 4 on top, 1 on the bottom, and I'm multiplying, whoops, I did the M early. 3/4 times 4/1. Multiply the top is 12, multiply the bottom is 4. Oh, 12 divided by 4 is 3, check. Got the same answer they did without the sketching of the number line. So you can see where this strategy might be more efficient if you just need to get answers quickly. You don't want to draw out the entire model or the entire number line and do a bunch of reasoning about whether it makes sense. There are some times where you just need to get accurate answers, and this is a great strategy for that. If I look up here to this problem we solved, just to do one more here, 10 divided by 2/3. Let's see how that would work with our strategy and if we can really get that answer of 15. 10 I'm going to keep. 2/3 I'm going to flip. I'm going to make it 3/2 and then I'm going to multiply instead. 10 times 3 is 30 divided by 2. Oh, look at that. 30 divided by 2 is 15 because 15 times 2 is 30. Well, this seems to be working quite nicely. So I just want to go through some of the problems on the bottom of this page in case you didn't want to draw out a model for every single one. Maybe this is a great place for you to practice this strategy. So we're going to just do a handful more together. If you want to pause the video and try them on your own and then check them, feel free to do that. Otherwise, we'll go through these few together. Don't worry, I'm not doing all your work for you. I'm still going to leave a few for you to do, and of course the back of the page too. All right, number 5, 4 divided by 2/3. We're just going to rewrite this with our KFM. 4 stays the same, 2/3 becomes 3/2 flipped over. Now I'm going to multiply. 4 times 3 is 12. Denominator's 2. We know fractions are division, so this is really 12 divided by 2. My answer should be 6. Notice this is still working with our generalizations up here. I have a whole number divided by a fraction. Yes, my answer came out bigger. So that's always something you can think back to and check, did I do this strategy right and do I have the right kind of answer? Okay. Oh, here's a different one because now I have a whole number second. Let's make sure it works here. This time I'm keeping the 2/3 and I'm flipping this one. So it used to just be a whole number 3, but we know now we can rewrite that into 3/1, which means I can flip it and make it 1/3. Okay. So then my answer would just be 2/9. Okay, be careful with that one. That's the kind of problem where it's easy to make a mistake and just put thirds here, especially because we're used to that adding and subtracting where we don't change the denominator. Remember, with multiplication, you do. So you need to do the 3 times 3. Okay, and now I can check with my generalization. I have a fraction divided by a whole number. My answer should be less than, and it is. 2/9 is less than 2/3 because ninths are smaller pieces. So that worked out well. That was a good one to check because it's a little different kind of problem. Number 7. 6/7 I'm going to keep. 3/7 I'm going to flip into 7/3, and then I can multiply. 6 times 7 is 42, and 7 times 3 is 21. Oh, that's interesting. 21 goes into 42 twice, so my answer should be 2 wholes. Does that work? Fraction divided by a fraction. I should get an answer that's bigger than. Well, 2 wholes is bigger than 6/7, so that works beautifully as well. All right. Keep 7/8. Again, I have a whole number, so I changed it into 3/1. And now I can just flip it into 1/3. Okay, 7 times 1 is 7. 8 times 3 is 24. Gee, that looks weird. Can I change that into simplest form? No, I can't, because 7 is just 7 times 1. 24 is not a multiple of 7. So it's not a fraction I'm used to seeing, not one of the common ones. It's important to check, but No, it's already in simplest form. Last one we have here, number 9. Okay, I'm going to keep the 8. I'm going to flip the 4/5 into 5/4, and then I'm going to multiply. 8 times 5 is 40, and the denominator is 4. Okay. 40 divided by 4 is 10, so my answer should be 10 wholes. Okay, so those are just some examples, at least one of each kind of problem, where you could use this KFM strategy and get through these problems a little quicker and still get the right answer. Now, if you're really not sure you're doing it right, you feel like you need a little more practice, you can always check with these generalizations to make sure your answer is reasonable, or you can always sketch out a number line or a picture to check and make sure that you're doing the strategy correctly. But if you can remember how to do it, burn it into your brain, this should be the easiest way to get the answers to these problems. So you can do the rest of the problems on 915 on your own, and of course the word problems on 916. And if you have any questions, you can check with your teacher the next time you meet with her live. It's been a pleasure working with you, and I will see you again in a couple of days.